things such as the history of the patient, the actual hospital, or the country. You cannot go and look for it because that data is not available. And this kind of brings us into the integration layer, which is a layer that is always inherently determined at the end user. So we are already using elements. The integration layer ends up defaulting as using these chatbots, such as ChatGPT, etc. Because you have to actually look for the ticket, you have to look for the guidelines, you have to look for the lab result, and you also have to look for the case report. And this also creates a big constraint in terms of how much work you need to be able to do. So you want to look for whether it's guidelines, etc., and response to that, and this can also cause a lot of issues as well. Accuracy can miss confidence, and also just takes a lot of time. So this is where you want to come with the model banks, in the sense of whether you're using these models or way to actually interact with the real world. So that's using an API. API or BCP server, depending on which works for that specific program. And this allows us to this is an example of an EHR net-based agent. This agent.
I think we lost you for a while, so if you can just go back in 2 minutes.
Okay. What's the last thing you said? Okay. So when you give these models access to an SQL API, they kind of have, in terms of layman's terms, superpowers. They can do things you probably wouldn't think an animal would be able to do. In terms of being able to get the data from different applications, being able to automatically retrieve information that you maybe even lost. And I said in this one, I'm sure you guys heard it, but I'll give it again. At our business, we had an issue where we were losing connectivity between our CRM, the amount of calls we had booked, and just a lot of scattered data. And we connected every single app and platform that we use on a daily basis to be able to then use these models for us to be able to process as our personal agent and to be able to aggregate data from different sources, which really saved us a lot of time because it stopped our own, not our own research, but the research that we do for clients instead of finding the information to solve a lot of the issues. And I'm actually sure you guys will demo which I have here, which is an EHR navigator. It's just kind of to visualize the way of how it works behind the scenes in the center. So, for example, you have a clinician and you want to ask this question: what are the results and the dates? And you want to ask the question: what were the results and the dates of the patient's latest LMP and CBC test? So we ask this question, and the model then looks through the EHR and actually kind of you can trace each and every step. Sorry guys, I'm talking a little bit too fast. This is So you can look through each and every single step. And I will give you just a quick rundown. So the LLM, which is the one that you follow, looks at what one question of which is this. It then looks for the tool and needs to code. So I was looking for patient's information. And you can actually backtrace everything. And I think this is one of the most important things in terms of in healthcare, because healthcare is really important that every single decision that has been made to be able to trace it back, especially if an AI has helped you find a patient's, let's say, lung. If there's a mistake, it needs to be able to trace where the mistake goes, where the mistake happened, so you're able to fix it. And you're able to fix the model or the team. And here's just a sample answer that we have just a model. And this is just a basic way of explaining how I explain the tool work. So the three things that chatbots cannot do is they cannot call tools, they cannot plan, and they cannot self-check. And this is where systems actually come in handy. And this is where it makes it really scalable as well, because currently we're using chatbots and LLMs, etc. It's not scalable, meaning you're unable to put it into your business and into the business or the hospital in a way where it's fully automated from step A to Z. And that's something which most large LLM companies will try to solve. And that's why you see these big investments or announcements such as Microsoft, etc., busy putting in LLMs into the actual process, because the reality which we have found out since the research that we see about this is LLMs are pretty much a very key business unless they put in the system. So that's pretty much right. And there's just a summary of the difference between promising and the system. So promising, long story short, is you do everything. And the system is you ask and then you do. It makes things so much easier, and it will be much easier, much faster, and makes the results, I believe, way more effective. So an example of a identification that I have created for this use cases, and I will tend to fever. She has a fever, and I say that for the last 2 years. And we will go back to that actually this now, but when you're also looking at creating solutions for problems with AI, we need to also look at the jobs that needs to be done. So these are just 5 thoughts that I came up with on top of my head as on the very good. Was you need to find the one answer, let's say you find the one answer very strong page records. You will be able to take history for the machine result. You will be able to explain the form to the patient or to the tutor. You need to be able to train the students when no one starts to speak and not the students to work and name what they say. So, and now we move on to the radiology demos. But before then, I want to just give a quick background on what I'm sure you guys already know. So, during my research, I found out in the city or town, HO is only 2 radiologists in the area. No mistake, I don't make a mistake.
You can just sound syllable. You can just sound it.
Sorry?
Just sound it. Sound the H. Oh, that's good.
Sorry, guys. Sorry?
No, you can go ahead.
Okay, perfect. In the town of York, there is only 2 radiologists, which I found out, I thought that was normal, but then I found out it wasn't. Because against the WHO guidelines, it's supposed to be between 100 and 150 radiologists per 1 million people. But in the city or town of York, there's only 2, and if I'm not wrong, it's about 1.3 million people per radiologist in that town city. And Ghana had a massive shortage of also radiologists. 7 provinces in Ghana do not have a radiologist. They have have the machines there that we actually, and the images are taken, and nobody in the region actually knows. And this is where I'm going on to the next spot of the presentation. And here's just some figures. And they asked a couple frontline doctors on what they actually do in terms of to be able to fulfill their job in the best way. And they all said, well, the aids in teleradiology and artificial intelligence as most of the things that include unnecessary research. So this is not really a forecast. Computer aided detection of X-ray systems are already prevalent and working before the access actually to and WHO and the Red Cross actually suggests something like TB screening and adults 15 plus should actually have AI or machine learning instead of this. So this is a demo based on Google. It uses both fundamental and analytical demo. So demo is a specific model which was trained by Google and a team of DeepNet. It's a great model because it's open ways and open source. It is very, very good at reading X-rays and very, very good CT scans. So here's just a summary of a report which was made based on this X-ray. I'm not going to try to do these, but I'm going to do that second, so we just do one more story. Sorry.
I think one of the medics here is trying to say he wants to look at the X-ray.
Sorry.
He's trying to look at the X-ray to report even before what is done. Yeah.
Okay.
Can we see the edges?
Can you see the report?
The full report. It looks like, yeah.
So, under we are going to see the lab is slightly outside. We say no possible minus light.
Yeah. So, I think I see there. Great. Now you can continue.
That's fine.
And then there's another example.
Minana, I think there's a little consider many numbers. So we can wait. Documents at the end of the year.
Well, no, we can have the discussion. I think it's actually better.
Okay, great. So we can come in with the point.
Okay. So, we are making a papers apart from the and we're looking at it value in what do you call it? Filling our medical student transport. As of the extent, we already have the physics. We are building them and to have more. But the medical students, we don't build a strong foundation for the education program. So, some of the terms, yeah, the choice of words and the terms, like there's either enlargement. Yes, we don't think when the enlargement alone describes what we want to see. The opacification, which comes from the Latin word, describes it much better. So we feel that this is a great start, but it needs to be improved upon over and over again by clinicians. So we need to get clinicians to use this over and over again. And once we are using it, they should have the option in which the clinician can actually suggest the technologies to be used. Or the clinician, let's say, what if I'm consulting with this and this with this report, I would say the conclusion is very good. And I understand the words and terms used there. However, if it is put this way, that I should bring out for mental health issues, there are five factors in there for you. So that will be continuous training for your AIS. So I think
So I think you understand what he's saying. I mean, essentially, these are assisted by the consultant. So if you put it up, you are not a trainer already, but that feedback is not about the head. You want to hear what he's saying. Clearly, this is a highlight. You think that the left side of the message more problem is everything. And then based on the history of code, we think this is something you're ready to go as a clinician. But I think the feedback is that training medical staff, I think we should have a layer for training so that we do the right thing. So classification and this so before we come to this the conclusion of it.
so that there will be drop-downs, maybe for medical students, for clinicians, when they select, they get the right technology, the right training. But this is a very
Sorry. So I actually had this conversation 2 years ago with OC. I'm not sure if you guys remember. It was one of the
I'm here.
So my idea on this whole demonstration is that I'm a tech guy, I'm the guy behind the laptop usually, so I'm not the great speaker. But I find this very inspirational in the sense of this is just a model you can download from GitHub online and start using. And the way that this is set up at the moment, it's actually not nearly as much as the prototype. You can actually go into extreme detail to show you can actually go into extreme detail where when you click on the settings, you can see what this means. And these models are really, really good where they are able to then get well, they're able to customize them in as much detail or as little detail as you want. So it's not as if this is what I've given you and this is all you can do. These type of open source models or open web models. They are so customizable. You can take it from a single application, you can make it into a multi-step different system in the same mode, using other models to think on Anchor. My idea with showing you guys as well, this is just for you guys who are creating juice to go, so you know, okay, this is actually possible with AI, we don't need $100 million for us to be able to invest in creating a system or educational tool or a clinical tool for clinicians. That's why I think this is one of the biggest things here. That's why I'm such a big proponent on open weight models and open source models, which I'm explaining a little bit more in my other conferences. But yeah, it can be customized to your full pleasures. And I have another example here as well. This is a radiology movie. I made it really simple. It's really simple. This is WHO manual for diagnostic imaging as its main source. And be able to give different questions and answers. And I'm just going to answer any.
question or comment? I think so far the users are very excited. The trainers are also looking at how the trainees can actually benefit from that. So I think that is the part that probably we have to be talking. In terms of disability.
I think exactly to what you were saying, that it could probably be built in a way that as you log in, whatever your level in the system is recorded. So it automatically knows whether you're a resident or a student or a consultant or even a layperson. And so the information which is given out will be tailored to that level of information or training as well. And a lot of these things, sometimes it's just a very quick question you want answered. Is there pneumothorax? Is there no pneumothorax? So if that's all you're looking for, and maybe the person does have something, right? The concern I have right at this moment, for which I did an X-ray, was, is there a pneumothorax which I need to put a chest tube in? Is there something more urgent? And you can also spit that out just for that level of interest that you have.
I think you can train somebody, you just get that normal. Anything he says abnormal, flag it for the yeah, that's a good sign. Yes.
So, you know, so this is the front end. So thinking about the back end, how is the cataloging and the archival system like? Is the data retrievable so that with time, even though we retrieve the data to follow up our patients, we also retrieve the data for research purposes?
I didn't understand the question.
But these are your images you're putting out the different
Yes.
It's your image. So if you ask me to retrieve, we already have it. That's what it is. You don't get it. So at the clinic.
Not only that. So it's supposed to be the two, I'm sure the two have a consultation interface.
No, so he's then showing what is possible. And he is using publicly available x-rays to do the training and show us what is possible. But if you are using it, after the training is done, you have your x-rays. So your x-rays are available.
I get you. But your x-ray should be interpreted.
Yes,
You
you
probably would have added,
to
probably would have put in history already, because don't forget, we started by showing us the layout of the whole AI model is building. There's a portion for history, there's a portion for guidelines, there's a portion for lab inputs. And based on all of that, so it's basically official that.
Yes, that is another concept.
Exactly.
Agent that you show.
Maybe Milena will explain that there was another, it's like using labs. This is also another system in terms of people.
But it can also be used.
You get it? So you are not, Milena, maybe can you speak to that? What he's trying to say is that this final feedback we get from the X-ray starts from the history and the labs that we talked about. Is that the case?
So they independent. So even if there's a quick, this is summary, a different summary. Is when you're using these X-rays scanning, you're actually using the patient X-ray, and you can actually combine the first aid of that should. For example, this has history of scarring along the chest, tissue.
This is really information you have to take. So if you say it's retrieval, then understand everything. Use your own data you are inputting to make a decision. So
you're supposed to be able to store the various aspects of the data you are putting in. You are supposed to be able to store it, retrieve it as a full data of the patient.
yes. Are you asking that it should have a template for generating a
Yes, so that when you have 1,000 patients of those that you want to run the study on it, another study, just retrieve that.
I think you are 3 miles ahead. What you are 3 miles ahead. This is a system supposed to help you in the clinical results. You take a decision, you have your EMR or EHR with you. After we are using games, you cannot integrate games at this one now, maybe in the future. So once you are with your games record, you have explained with the next one, you can go into the system to get this and then continue with your test. You get it, but you are looking at a one-stop system where, maybe in the future, that's what I'm saying, you are 3-4 steps ahead of us.
But I think this one, just the report on the election, if it's cheaper or excuses, because that would also be a part of the sanitary
everything is in like a searchable way and you can so when you go at it, you see everything.
and then you choose.
Everything, all the systems that have the database, so the database should, if it has the right like information, it will all come. So for training purposes,
Yeah.
you can do that.
But I agree with that. You see, I'm saying this because, you know, I'm also pleased with the we say a lot, and we report fairly. If we are good to do reporters on our bodies, we know, even from the time that we started, our, the kind of business we can publish for the so I'm thinking about
We understand it, but there are systems for that as well, for taking history. Systems where the person can speak, and then we give you the record. And your interaction and everything, we give you the whole
I
transcript.
get it, but what I'm trying to say, I thought this started now. Is this the issue about what is now?
It should be.
Can I ask you a quick question? These systems, at least to my knowledge, even when it gives the reports, doesn't it still have to have a human radiologist approve the report? Okay. So to the extent that we're concerned about details, I think even if it doesn't give certain details, the human radiologist will add an addendum or something at the end indicating that this is additional information which was needed. But at least it speeds up the process.
And finally, you have to be responsible, not and that is why you don't have to just. And this is helping you. No, how many minutes, is there any other thing you want to show before we round up?
No, so I want to.
But you can go ahead, we just want to know how many more minutes, is there anything else you want to show before a question comes out?
I'm still going to show you guys, and I can see the answer.
So there's a question here, and then we go on to.
Yeah, so I would just like how sensitive and reliable is it?
Okay, that's a great question. So these models have certain scores which are published by people and set probably here. But there are certain scores, and I think this model gets it right. It's 80% of the time wrong. And the best part about it is it's the baseline. So what a lot of companies have been doing, for example, the Red Cross, it's the Red Cross. Then we really in Central Africa, it is just actually they started fine-tuning these models to make it really more. Sometimes this is what they're doing. When you start adding certain details such as how does it analyze to look at how do you look at x-rays, how do you look at images, and start fine-tuning the model in a way where it actually solves your problem. It's actually looks at a certain thing that it becomes more reliable than anything. So hospital docs has a certain score. But then if you guys at the hospital decide, okay, we're going to spend some time with our head professors to sit down and have conversations with each other, and we're going to speak on how we have these models. Instead of take our pool data, where it's, we're going to take 10,000 pages of different x-rays that we've done, or 10,000 pages of different notes that we have for certain illnesses, and you put it into the model, the accuracy will actually go up. So that kind of agreement with this model, you come at a baseline, and how you use it afterwards, you can change the actual score.
Because the more you use, it's actually learning from us. We are not like that. From us, that's what you feel.
So then you can go on with the last 2 seconds.
This is just a demo which I created created an AI system like that, where students are able to train in speaking and talking to a patient and actually going through the steps. So here's the basic model. So I'm going to be talking about tools and models, so you guys will see once a minute. But it's going to be a bad question for me, but maybe it will make sense. So, let me know if you guys need it.
Doctor, I've had fever for 3 days now, and my head won't stop hurting.
Oh, sorry to hear that. Have you had any new medication in the last couple of days?
Some tablets sell out at the Nordic station maybe. I do not know what they are.
Okay. Have you been changing your lifestyle days slowly?
No, everything is the same. Just feeling very sick.
Okay, perfect. So we can go all the way down. Here's one of the questions that they are essentially to ask you can take context on the situation. And then you go here, you can take the vitals. You can examine the patient. So here is a brief summary of diagnosis. Thyroid, listening, stiffness, chest is clear, spleen, etc. Okay, all the tests is necessary, so if you're an analysis. And you see a prescript and you can finish consult. And then now, once you make the diagnosis, I'll say and then you give a scope at the end of it. And obviously, I'm going to make it super detailed, but here you have a super detailed investigation. You went wrong here, you should ask this question, you should remember there. Yeah, that's just an example of the science simulator for students.
Recently, at the consortium of medical schools in Africa seminar we had about 2 weeks ago, we had sample presented. And it's a nice, which you can actually do at that time. But other than patients, and then we do many scenarios as much as possible. So I think that's a very good one.
So that would be our first topic on before all the starts.
Yes, you can actually. Even the point is, because of numbers, currently we do a lot of opportunistic learning. So you can do all around that. And I don't remember the last time I saw my judges of programs. So what it means is that after a while, the students will forget that there's even meningitis. But you can actually be deliberate about this. That we are going to do meningitis. We go through this, what the managers did for the meningitis case, all the way to our number of everything. I think that makes a quite extent. So these are things that we'll definitely be looking at. See how. Great.
Well, is it beyond exist? I think available or it's a new baby now.
Well, is asking them is a new thing we are developing now. But the other models are he's also developing different concepts and different ideas. I think it's why I said he's hoping for input, so I think it will be great so that we can contextualize it here. The experiences we have about Next,
I was thinking it's available, just so you know, it's available.
yes, in your case, what we have is there's the what you are demonstrating now. Is it a finished product? Is it a finished product? Can one assess it?
We thought about it about 3 years ago.
Yeah.
Produced this.
Just for this
presentation.
No, so I think Professor Numo actually explained to us exactly the task and what you've been able to deliver. And it's great. We're just commending you. Oh, you are saying you are good. You are right. You are saying you are right. Okay, so we can go on to the next one.
So this is just kind of basic explanation, but I think it's really important for you guys to They're open and closed model. So what is a closed model? It's OpenAI, so ChatGPT, Claude, Gemini. Those are closed models. Meaning, a lot of the things that you're able to do in terms of really customization, I mean creating a really fine-tuned healthcare app for your university, it's really difficult with the frontier model, which is a open source, which is a closed model, which is very expensive to develop as well. So there's just estimations on how much it actually costs these companies to develop their models. So GPT-4 was $70 But when you're looking into closed model, which is what I'm proposing for the university, it solves two issues which closed models don't have. Well, yeah, closed models don't have this. Closed models, number one, it's stored outside variables. So if you are talking about legal patient care, details, etc., they all rules behind it, and also makes it very difficult for you to be able to do an enterprise level contract with these OpenAI, Anthropic, Google. However, when you use an open source model, a model which is open, for good example, GDK3, GLM, DCP, Vivo, Dashboard, Gamma, the medical AI that I showed you as well. This allows you to actually host it on your own server and host it locally at your own. You guys have full data sovereignty. So no one can come to you and take your data. You guys are in charge of all the compliance that you have to meet as an institution, and it's really critical for you guys to have this. And as well, when you're using closed models like your ChatGPT, you are subservient to them. Meaning, if they change, or a certain president in America decides, okay, from now on, I want to force that they are forced to do it. So this also gives a lot of security and sovereignty by having closed open source models and be able to function and improve as well, because it's the one thing in the world that is giving Africa, Asia, South America, the competition level with the West. Because we don't have to spend millions of dollars, because the Chinese are doing that to make these models really good. Then all you have to do is come in and fine-tune them and build them to the way that you want it. And instead of spending millions, you spend 10,000, you spend 50, I mean, sometimes you spend 100,000 to fine-tune models. But it's a really good output because it gives you data sovereignty and also sovereignty to decide how do you want your models to work, how do you want it to answer, is there anything that you feel is wrong? So that's the last part at the moment. But if anyone wants to see the slides or